So let me start this video with a question. So majority of the applications belong to the client server architecture type, but there are some very powerful applications belonging to the peer-to-peer architecture. We will see a few of these in the next few videos. But first, let's start out with an overview. So we have been telling peer-to-peer, peer-to-peer. What is this peer? A peer is nothing but a user device like a desktop or a laptop or a smartphone. So these are the devices that are managed by users. And what do they contribute? They can contribute resources in the form of their computational power, that is the processing power, the bandwidth, the link speed that they are connected to, as well as disk storage. In peer-to-peer architecture, any application functionality that you wish to implement is realized by leveraging the resources that are provided by these peers. So basically, the architecture distributes application functionality across all these peers. And these peers are often equal, though this need not be true in all the systems. In some systems, some peers are more powerful than others. And these peers, by the nature of the peer-to-peer architecture, will act both as clients, that is the consumers of data, as well as servers, that is suppliers of data. So what are these peer-to-peer networks used for? The predominant use is in file sharing. So these are used for sharing movies, songs, software such as Linux distributions, which can be very large, software updates, games, so on. These are also used, for example, in multimedia applications. The popular Skype is based on peer-to-peer architecture. And there are a few other miscellaneous use as well. So Bitcoin also is peer-to-peer based. You can implement web caches based on peer-to-peer architecture as well as distributed databases. But in this course, we will look mainly at file sharing applications built on top of peer-to-peer networks. So this file sharing can be done using a client-server architecture. Then why bother with this peer-to-peer networks? There should be some advantage these peer-to-peer networks provide. That is why we are even considering them. So to understand this, let's consider distribution of very large files. Now, if client-to-server architecture was used to serve these very large files to a large client population, what do you think the problems are going to be? Well, for one, the server needs to be always on, and it has to be very powerful, by which I mean the processing capabilities of this should be very good because it has to serve a large client population. Not just this, in order to serve this large client population, the server also needs to be connected with a very high speed link. In other words, it needs very high bandwidth to support such large client populations. So all this basically implies you have to invest heavily on your servers. So this is going to increase the cost of your system. It is very difficult to scale these systems. In other words, you can only scale them by throwing more money at the problem. The servers often become bottlenecks and crash when too many clients are connected to the server. Now, how does peer-to-peer help? Now you can leverage on this very large client population. In other words, you can utilize all their resources, including their processing power, bandwidth, so on, in order to achieve the required functionality, which in this case is distribution of large files. So your cost is going to come down significantly because you're not investing much. The clients are the one that are contributing their resources. And this is a very important point, that the peer-to-peer systems are highly scalable. Now, as the client population becomes larger and larger, the server will start facing more and more problems if you are going for a client-server architecture. Whereas in peer-to-peer networks, as more and more clients are joining the system, now you have more and more resources also added to the system, which basically these new clients that are joining bring into the picture. So as more and more clients join, it will scale accordingly. So that's a very powerful feature of peer-to-peer networks. But naturally, there are some difficulties associated with peer-to-peer systems. What do you think these are? These peers are not always going to be there saying use me, use me. So they are going to come and go. In other words, you are using your laptop, you come on sometime, you do your work. While you're doing your work, you're happy to share your resources, but once you're done, you shut down your laptop and go. So this intermittent connectivity is a very big challenge in peer-to-peer networks. So you may have a very large peer group to implement your application functionality, but at any given time, not all are going to be available, and this set will vary over time. So that is something one has to keep in mind when designing these applications. Since we are interested in building a file sharing application, leveraging the peer resources, let's first try to understand this problem well before proceeding further. So basically the goal here is to help users share files among themselves. So this figure captures the picture. So there is this user Sita who wants the song by Pink Floyd, Another Brick in the Wall. And she's also ready to share two other songs. One is Stairway to Heaven and another is Bohemian Rhapsody. And here is Geeta, who is ready to share Another Brick in the Wall, but she wants Hotel California. And there are a few other users. For example, Ravi wants to share Another Brick in the Wall and Raka is ready to share Hotel California. So the goal of file sharing is to keep the necessary parties in touch with each other. In other words, since Geeta wants Hotel California and this is available by Raka, so you need to put Raka in touch with Geeta. And since Sita wants Another Brick in the Wall and this is available at Ravi as well as Geeta, so you need to put Geeta or Ravi in touch with Sita. Now let's say Sita chose Geeta to download this Another Brick in the Wall. From the perspective of Geeta, notice that she is acting as a server when she is uploading Another Brick in the Wall to Sita. That is, she is giving this file to Sita. That is what we use the term uploading for. And she is acting as a client when she is downloading Hotel California from Raka. So as you can see, Geeta is acting both as a server to Sita, and as a client to Raka. So naturally there are a lot of questions we need to answer before realizing this functionality, like how does Sita know Geeta has the song? Or how do you enable communication between all these different peers that want to talk with each other to search for songs? So before we proceed, why don't you spend some time thinking about how you can implement this particular application using these peers? Well, one thing is fundamental. These peers need to communicate with each other to be able to figure out who has which file, how to get that file, so on. So communication is very essential among these peers. And to facilitate that communication, one needs to build what is called an overlay network. So if you see here, this is the routers that are interconnecting these peers. Basically, this is the internet that is interconnecting all these users. And we are now going to overlay a network on this internet. And this network is fully formed at the application layer. So here the nodes in this overlay network are the end users like Sita, Ravi, Raka, so on. And the links you are establishing between these users shown in this red line could be TCP connections. In other words, you are going to establish a TCP connection between Sita and say this other computer, let me call it A. And in order for the packets to go, basically they will use the router and go in this particular fashion, but we are putting a direct link between them to indicate that there is a TCP connection between them. So as far as the application is concerned, for the application, the view of the network is the network formed by these red edges connecting all these hosts. So similarly, if you see A is connected to Raka by a single red line, that is the application view, but in reality, whatever packets A is sending to Raka actually will go in this particular fashion over many hops, as you can see. So this overlay concept is very important to understand before we proceed further. So let me quickly summarize. So there are all these peers which you need to interconnect, and you're interconnecting them via TCP connections. So as far as the application is concerned, the view of the application is basically a network that is connecting the host with these red lines. In reality though, whenever you're sending a packet, the packet actually goes all the way down the protocol stack, over routers, over many hops if necessary to reach the other endpoint. So there is some functionality every peer-to-peer application needs to implement. So this is join. For example, how does a user join the peer-to-peer overlay network? How does a user advertise files that he is willing to share? This is called publish. Now, how does a user find a file? This functionality is search. And how does a user download a file? That functionality is fetch. The peer-to-peer applications we are going to see in the future, we will understand how these applications are implemented specific to these primitives that I am mentioning here. And again, let me emphasize the challenge of peer-to-peer application design. One challenge is what we call churn. The churn is where peers come and go. They have intermittent connectivity. Not just that, each time they come and go, the peer's IP address can also change. So this makes the problem more difficult. Another aspect which you need to understand before we cover the actual peer-to-peer applications is that there are two types of overlays. One are called unstructured overlays. In these overlays, the edges between the nodes are randomly formed. In other words, when you are adding a new node onto an existing overlay, that new node will connect to nodes in the overlay. It will just randomly choose existing nodes in the overlay as neighbors. So for example, in this figure, let's say I'm adding a new node N, it may randomly choose to connect to Ravi, it can choose to connect to this A, and it can randomly choose to connect to Raka. So it just chose randomly and established these TCP connections, and now it is part of the overlay. So such unstructured overlays are very easy to build. And they also offer some robustness against churn because there isn't any structure to them. However, the search is very inefficient over such networks because there is no structure to it. Everything is random. In contrast to unstructured overlays, there are these things called structured overlays where the edges are arranged carefully to speed up search. So this way, even rare files that are very difficult to find using unstructured overlays, it becomes easier to find because you're establishing a structure in the overlay to help your search functionality. Such structured overlays are based on the concept of distributed hash tables. This is something interesting for you to look up. So these structured overlays tend to be very complex because you have to impose such a structure, and thereby they are going to be less robust against churn. So if your peers are coming and going, you have to reimpose the structure again and again. That tends to complicate things. Lot of the applications we will see later are based on unstructured overlays. So that is what our focus is going to be.